Okay, in this video we're going to look at solving equations, more specifically equations with fractions in them, and we're going to use a method called clearing fractions. Okay, and if we do get a fraction for an answer, we're going to leave our answer as a fraction. Okay, so in question number 1, we have 2/5 x minus 8/5 x equals 3/5. Now, one way you would have solved this in the past is to look at combining like terms on the left-hand side. Well, notice how 2/5 x minus 8/5 x, they have a common denominator, which is good. We're subtracting fractions, and remember, the rules with fractions is whenever you're adding or subtracting fractions, you have to have a common denominator. So this one isn't too bad because we already have the common denominator. So one way to solve this would be to combine those x's together. So 2 minus 8 is -6. Keep the denominator, and then times x equals 3/5. Okay, and then to undo, or the opposite operation of multiplying x by -6/5 would be to multiply by the reciprocal, -5/6. Okay, and if you do that, again, the 6 and 6 reduced to 1, -5 and -5 reduced to 1. So you'd have x equals, when you multiply this together here, you can reduce the 5's again and reduce 3 and 6 to 1/2. So that would be x equals -1/2 for an answer. Okay, or you can take this step right here and you can divide by -6/5. So do 3/5 divided by -6/5, and you should get x equals -1/2 for an answer. Okay, now there's nothing wrong with doing it that way. Okay, but that's a very basic example, and it's set up for you to actually be able to combine those together without too much trouble. Okay, because they already have the common denominator. Okay, what clearing fractions is going to do is basically get rid of fractions. Okay, and that should be music to our ears because most students and most people hate to deal with fractions. Okay, so another way to look at solving that equation, okay, would be to look at the denominators, 5, 5, and 5, and you ask yourself, all right, how would I be able to get rid of or undo dividing everything by 5? Well, you can multiply everything, or each side, by 5. Okay, or 5/1. So what happens here is 5 times 2/5, the 5's reduced to get 2. So we have 2 times x. And then 5 times -8/5, again, the 5's would reduce, and we're left with -8x. And then on the other side, 3/5 times 5, the 5's reduce, you're left with 3. So when you compare this equation with the second step over here, which was, I'll just write it again real quick. It was -6/5 x equals 3/5. Okay, when you compare those two equations, most people would say that 2x minus 8x equals 3 is better looking or a little less complicated looking than solving this equation here. -6/5 x equals 3/5. Okay, so 2x minus 8x, combine those together is -6x equals 3. Divide by -6, reduce it, and we get -1/2. Okay, which is what we said the answer was if we did it the other way. Okay, question number 2. On this one, when we look at the denominators, okay, if I look at the -2 here, that's -2/1. Okay, so just make every term into a fraction. Well, here, if I were to try to put the x's together, I'd have to have a common denominator first because I'm adding fractions. So that there'd be a step to do before you actually were able to add them together. Okay, by clearing fractions, what we can do is look at all the denominators, 4, 2, 1, and 2, and what is the least common denominator? Okay, so what is the smallest number that each of these, 4, 2, 1, and 2, would divide into? Well, 4 goes into 4, 2 goes into 4, 1 goes into 4, and 2 goes into 4. Okay, so the LCD is 4. The least common denominator is 4. So what we can multiply each side, or every single term in the equation by, is 4. And if we do that, 4 times 5/4, you can look at that as 20 over 4, which is 5, or the 4's cancel or reduce out to get 5x. 4 times a half x will be positive 2x. 4 times negative 2 is negative 8. And then equals, you can do 7 times 4 is 28, divided by 2 is 14. Or you can reduce 4 and 2 to get 2, and then 7 times 2 is 14. Okay, so then combine like terms. 5x and 2x is 7x. We can add 8 to each side. So we have 7x equals 22. Divide by the 7, and we get x equals 22/7. Okay, so you can see there again, the whole point of this is multiplying by the LCD, it eliminates the fractions, okay, which most people are more comfortable with, getting rid of the fractions. Okay, number 3, okay, is a little more complicated. We look at 3, 6, and 12. So the LCD is 12. 3 and 6 both go into 12, and 12 goes into 12. So we're going to multiply every term, or both sides of the equation, by 12. Now when you do that, you have to be a little bit careful here. When you do 12 times that first fraction, what you can do is you can reduce the 12 and 3. 12 and 3 reduces to a 4. So I'm just going to show 4 times 2n plus 4. Okay, so that's what this was right here, 2n plus 4. And then 12 times negative 5n minus 7 over 6. Well, the 12 and the 6 would reduce to a 2. So we have minus 2 times 5n minus 7 equals, over here the 12s would reduce out to just get 11. Okay, so this equation is still a little annoying, okay, but the fractions are gone. Okay, so that's good. The fractions are gone. Distribute the 4 to the first parentheses. That'll give you 8n plus 16. And then negative 2 times 5n will give you negative 10n. Negative 2 times negative 7 is positive 14. Equals 11. We have 8n and minus 10n on the same side of the equals, on the left-hand side. So that's negative 2n. We also have 16 and 14 on the same side. Adding those together, we get positive 30. And then bring down the equals 11. We'll subtract 30 from each side. So negative 2n equals negative 19. Divide by negative 2. So we have n equals negative 19 over negative 2. And then the negatives will, negative divided by negative, end up with positive 19 halves. So there's your answer. Okay, so that is a method called clearing fractions. Okay, the rest of this page is a little bit different. Okay, this is solving equations when you have several variables. Okay, more than one variable. Okay, so given each equation, find the value of the missing variable. So a equals 1/2 b times h. You may recognize that as the area of a triangle. Okay, area equals 1/2 base times height. So if a equals 10, so if the area is 10 and the height is 4, we want to find the value of the missing variable. So the missing variable would be b. So if we solve that equation, we substitute what we know in there. A is 10, so we'll put 10 equals 1/2 b times 4. Well, we can actually do 1/2 times 4 because they're on the same side and it's all multiplied. So remember, multiplication is commutative, meaning you can multiply in any order. Okay, so 1/2 times 4 is 2. So 10 equals 2b. And then solve that by dividing by 2. And we get b equals 5. Okay, question 5. 2l plus 2w equals 50 if l equals 6. Okay, so if we know that L equals 6, how would you find W? Okay, this is actually the perimeter of a rectangle. Twice the length plus twice the width is the perimeter, 50. Okay, so if you substitute L equals 6 in, okay, we have 2 times 6 plus 2W equals 50. We know that 2 times 6 is 12, so we'll subtract 12 from each side and then divide by 2 to give us 19. Okay, these shouldn't be too difficult to do. The only new thing is just when you have several variables here, just substituting in for the variables and then solving an equation. Okay, number 6. Okay, this one's a little more complicated. A equals P plus PRT. Okay, what this is actually a formula for simple interest. So the amount you would end up with would be P is the principal, so what you started with, plus the principal times R, the interest rate, times T, the number of years that you're going to have the loan. So if P equals 2,000, R equals 0.1, and T equals 5, again, just substitute your values in for P, R, and T. Okay, so you do that. And then that's a pretty easy calculation. 2,000 plus 1,000 will give you 3,000. Okay, so in those 3 equations, we were solving for a variable, and we ended up with just one variable that we didn't know. Okay, we had one missing variable. Okay, in the first one was B equals 5, in the second one W is 19, and A is 3,000 in the last one. Okay, what we're going to look at now is we're going to be given similar equations, except now we don't know what all the variables represent. Okay, or we don't know the values of all the variables. So this may still be the area of a triangle, but we're not told what the area or the height was, or the base. Okay, we just want to solve for the indicated variable, so we're going to solve this equation for h, which means we want to get h equals at the end. Okay, we want to isolate the h. So we look at a equals 1/2 b times h, and we want to think about, well, how do we get rid of the 1/2 and the b? Because we want to get h equals. So this is 1/2 times b times h. Well, so to get rid of multiplying by a half, you can divide by a half or multiply by the reciprocal. Now, if you do dividing by a half, what you would end up with here is you would have a divide by 1/2. You would introduce a dividing by a fraction, and that's just going to be very messy looking. So rather than do dividing by a half to simplify it, we will multiply by 2 instead, the reciprocal. So really what we'd have, if you multiply each side by 2, 2 times a half is 1, 2 times a is 2a. So we have 2a equals b times h. Now, to get h equals, it's b times h, so we'll divide by b. So 2a divided by b equals h. And that looks messy, but we don't know what the area and base are. We don't know what a and b are, so we don't know the exact value of h. We can't simplify it any more than that. Okay, number 8, we want to solve this equation for a. So that means you want to get the a all by itself. So we have to get rid of subtracting b and multiplying by 3. Well, just like with other basic two-step equations, if we knew that b was a number, like say 5, wouldn't we add 5 first to each side and then divide by 3? Same idea here. We're going to add b to each side. So we have 3a equals 8 plus b. And then divide each side by 3. A equals 8 plus b over 3. Now you could also say a equals, you can, because we have we're dividing each term here by 3, you could also break it apart into 2 fractions, 8/3 plus b over 3. Okay, you can write it that way. Okay, either way is fine. Okay, number 9, you've actually done these before. You look at 2x minus 5y equals 7. This will end up being a linear equation. We're going to solve it for y, so that means we want to get y equals at the end. So we want to isolate the y value. So to do that, we get rid of the 2x first by subtracting 2x. So we'll bring down negative 5y on the left-hand side, and then the 7 minus 2x. You cannot actually combine those together to get 5x because they're not like terms. We just left with 7 minus 2x. And then to get rid of multiplying y by negative 5, we'll divide every term on each side by negative 5. So y equals 7 minus 2x, all divided by negative 5. Or, just like in the last one, you can break it apart, and you can even put the x term first if you want. Negative 2 divided by negative 5 is positive 2/5 x, and then 7 divided by negative 5 is just negative 7/5. Okay, so that's probably the best looking answer. Okay, move along to number 10. We want to solve this equation for c, which means we need to get c equals. So the first one we look at is we have b minus 3 times c divided by 5. So let's clear fractions. Multiply each side by 5, so they reduce over here. So 5a equals b minus 3c. Okay, a lot of students will try to subtract b first, but remember that dividing by 5 is under the b also. So my suggestion is clear fractions first, just like I showed you at the top of the page, and get rid of the fractions. And then we can go from this equation here. It's not too bad. So to get c equals, we'll get rid of the b by subtracting b from each side. Now 5a minus b we can't actually do because we don't know what a and b are. They're not like terms. So it's still, even though it looks weird, is still 5a minus b equals negative 3c. Do not forget the negative sign. Okay, and then to get c equals, it's negative 3 times c, so we'll divide each side by negative 3. So we'd have negative 5/3 a plus b over 3 equals c. Okay, then finally, question number 11. X over a plus y over a equals 1. We're going to solve for y. So we have fractions again, so let's clear the fractions. The denominator, the common denominator will be a. So multiply each side by a. So if you do that, a on this side, and then times a over here. The a's reduce here to get x. The a's reduced with the y over a to get plus y equals 1 times a, which is a. And then to get y equals, we'll subtract x from each side. So y equals a minus x. Okay, and there's your answer. Okay, so that takes care of solving equations by clearing fractions and then solving equations that have several variables in them. And again, those answers may look a little bit funky or a little bit weird, but the difference here is that we don't know the value of all the variables. Okay, if you have an equation with 2 variables, then you have to know one of the variables to solve for the other one. If you had 3 variables in an equation, you'd have to know 2 of them to find the third one. Okay, like in the area of a triangle, you'd have to know, in this case, a and b to find h. If you had 5 variables in an equation, you'd have to know 4 of them to find the 5th one. Okay, so sometimes you don't know all the variables, so sometimes your answers will have more than one variable in your answer. Okay, which is okay. You just have to understand what type of question it is.